Hello, everyone. Welcome to the binary episode of the Day Zero podcast for this week. I'm Spectre, with me is Z. In this episode, we have some questionable memory corruptions in Edge, a SHA-3 buffer overflow, and a Linux kernel bug in IOU ring. First, though, before any of that, we'll get into the spot the vuln solution. Technically, there were two for this week because I made a mistake. So there's an unintended solution and an intended one. I'll go through the intended one first. So yeah. The Spot the Vuln challenge had like this note theme to it. The idea is an attacker or a user can add notes and dump notes. So there's the add note and dump note function. They have control over the body size and the note that's being passed in for add note. Um, and right away on line 7, you can kind of see something that stands out. There's this unsigned type being used for the note size, which is notable because the body size is passed in as a size T. So the intended solution here is basically an int truncation issue. The note size is being set from the size of the header or the body size and the struct note added to the body size, but that's only going to be stored in 32 bits. So it uses that to allocate the note, initialize it, copy in the string, but then the dump note will use the body size, which is a full 64-bit type. So if you are kind of clever with how you set the body size, you set the lower body size so that it's large enough for the struct note size, but it's still a small allocation. You can then set the upper bits so that you get a large copy out and leak data that way. There is also an unintended solution because I do a memset on the allocation of the new note, but I only memset the struct, so the body size and not the body itself. And because a strl copy is used to copy in the string data, if you just put like a null byte in the middle of the payload or something, and you don't initialize the entire body size that you pass in, there's an uninitialized data read there too, because memcopy is used for the dump note, not stir copy. So the null bytes won't stop the copy there, and it'll just keep reading. That was unintended, but it is totally a valid solution to this as well.
Unintended. I think
Yeah,
it's also fair to think that the size will be constrained. Although in your original version, you actually had a main and stuff for this, which I stripped out due to size. You
yeah.
wouldn't
So
be
the
able
text
to
wasn't
put in.
absolutely tiny on the stream.
Yeah, I need to save lines here. I mean, 25 lines, and it takes up most of that starting soon screen. So having yet main and a little bit more, it really adds up. So I kind of removed that, but I didn't want to call it. In at least your original, you wouldn't have been able to put a null in the middle of a string because you were using args.
Yeah,
But you would have still had complete control of the arg used for size, so you could still give it a larger size than what the string is, but not a string, not a null in the middle. So just a minor discrepancy there, but I mean, you guys can't even see that code, so it doesn't really matter.
yeah. And I see in chat asking if we have a logo for it yet. Yeah, we haven't created a website for this issue yet. You know, but yeah, Notebleed, pretty good name, Vuln. So yeah, somebody should get on a site for that right away.
Yeah, you'll also have to get on implementing this into some real piece of software. So backdoor
Exactly.
something, add the vuln in, then name the vuln.
Definitely don't, but it would be funny.
Yeah, don't actually go and do that, but
Yeah. All right, so with the spot the vuln out of the way, we can get into some of our topics. The first of which is a post that contains a bunch of memory corruption bugs in Edge, and some fairly questionable ones in terms of exploitability and whatnot. Though they were paid a lot in bounties. So Z, I'll let you take this one away.
yeah, this week our binary episode has more in bounties than our bounty episode. I want to say this was like $186,000.
It was 215,000
Oh,
total.
I must have missed one of the 30,000 bugs then. Yeah,
Yeah,
because basically most of these bugs in here, just keep in mind most of these are awarded $30,000. And there's just a bunch of them through here, and then one of them's like 5 or 6,000. Uh, so on the very first one here, I'm just going to walk through that one, and then um after that, a lot of them follow a very similar pattern. So this very first one, use after free when selecting custom icon for web app. So in the Edge or Edgeum browser, they have a feature you can install a web app. Um, install this site as an app, go to the menu, and it brings you up this little dialog. Install app, give it the title, and you can change the icon. And so you click edit, it gives you the normal sort of file browser. That pops up. Now, if while that file browser is open, you go ahead and like click cancel or close the tab, just close this dialog and then close the file dialog. The file dialog will have like a callback. They don't actually go into what it did or like why exactly it happened, but there would be a use after free when that file dialog closed because it's trying to access that old dialog. And this was worth $30,000. Huge bounty. I mean, technically speaking, this is a genuine use after free. I don't know how you'd exploit this, like in the wild or for anything. Like this feels be in a similar vein as like a self XSS.
Yeah, like this isn't like just like a 0-click or a 1-click where it's like somebody has to visit a website and they can get exploited. This is like a 2, 3, 4-click or something, requiring very specific functionality to be used in a very specific way. So it is like you said, it's a valid memory corruption. As to how this is actually going to be exploited in the wild, I think it's pretty much impossible for almost all of these bugs, because it's just not something that somebody's going to do in a way that's useful to an attacker context.
Yeah, like this first one, I'm thinking, if you could somehow detect somebody starting to do the app install and like can detect when that file browser opens and like close your own tab and like cause it to happen, you maybe can get something like that. But some of these are, let me find one of them is this out of bounds. Yeah, out of bounds read when dragging a link over tab strip. On this one, what happens is you're dragging like a link, and you want to pull it into, I guess, your tab strip. If you do that while the window is closing, there's a brief period where there's 0 elements in the tab list that it will try and iterate over, and it doesn't check for like the end element, or doesn't check it appropriately, and so it ends up going out of bounds as it's trying to iterate over the tab strip. It's like you would have to hit this exploit at just that perfect timing. IABR hit something. I kind of thought about this a little bit. Would it be useful when in like a sandbox scenario? But even in that case, I mean, I'm still feeling like you can execute, you can get a file browser prompt that's usually enough to escape out of most sandboxes. Just being able to access that file prompt. So,
well, the other thing I would say is like in any serious sandbox machine, like maybe you could use it to get code execution, but you probably already have that if you're in a sandbox environment. I don't know. I just don't really think it's useful for a privilege escalation.
like it depends on what type sandbox you're thinking of. If you're thinking of the sandbox, like just the browser generally has a sandbox priv asking out of it, like that sort of sandbox, you're going to end up with these same privileges, so it's not really that useful. But yeah, kiosks are kind of the other place, escaping the browser, where you're just locked into the browser. And I mean, that doesn't come up here at all, and I feel like there are easier ways to get it, especially if you can access things like installing an app.
Yeah.
Usually the lockdown's going to be a bit different there. But I guess in fairness, like the kiosk situation is a good show. Like that is maybe a place where you could do this. I don't think that's where the current like meta is for kiosk escapes. I haven't seen much on kiosk escaping either, though, in quite a few years. Oh no, it was popular like I guess a decade ago now. Feels like it wasn't that long ago, but was popular for a little bit of time, but haven't seen it as much now.
I would be curious too on the distribution of like browsers and whatnot and how they're used in kiosks. Like I wonder how much Edge would be used
as a kiosk.
Yeah. I mean, it could be because it is like Microsoft's browser, the default browser. Maybe it is used more for kiosks than you might think. But
yeah,
I'd be curious on that.
Yeah, no, I guess
those are. Sorry, go ahead.
I was just going to say, yeah, it's a good shout actually. When I kind of had my mind on Sandbox, I was thinking about Sandbox escaping in the same sense of like, well, you're ending up in the same privileges you already have in the browser. But yeah, in terms of a kiosk, it's a fair shout. That is at least a possible place for it. But I feel like usually the way you get out of the kiosk sandboxes is easier than like browser memory corruption.
Yeah.
Maybe that'll change
Um,
given how easy some of these are, though.
yeah, I mean they are like the theme of all of these bugs is basically that they're in these weird attack surfaces that basically nobody is looking at. Probably partially because they're just not really good attacker scenarios to be in. But yeah, it's these weird functionalities dealing with like tabs and windows being moved or dialogues coming from tabs that are moved to different windows. Just kind of these weird edge cases that aren't really tested for or checked very well. And they found all these memory corruptions. Um, so yeah, they're fairly easy bugs to trigger. I don't know how easy they would be to exploit. Even if you could like feasibly trigger them, um, it would be because they rely on actions. Getting the timing right, I feel like would be very difficult. It's not like a JavaScript exploit where you can trigger something at a specific time and then immediately after that, like have things set up and ready to go. This is something where you kind of have to like preempt the event happening and work around that. So I wonder how reliably you could exploit these, to be honest, even if you could trigger them.
I'd be
Um,
interested in what the grooming looks like for some of these because, like, you use after free
yeah.
even out of bounds read, you're going to want to groom the heap for those. What does that look like? Like just opening a bunch of tabs, maybe opening a custom site, you'd be able to work that out. Just opening an attacker site. There might be something there, I guess. Yeah, I mean they're legitimate bugs. I don't want to take that away, and obviously they've got some great bounties out of them. I honestly genuinely surprised by the bounties the most out of this.
Yeah, that's the aspect that jumps out at you from this post is like getting $30,000 payouts for these bugs, um, because yeah, I mean that's kind of insane. Um, so the takeaway, I guess, is maybe if you're looking for some bounties and want to make some money, then you might be able to find some somewhat crappy bugs in Edge, and Microsoft might pay for them. Though in the conclusion of this post, they do say, in regards to user interaction, some of these issues, if reported today, might not be paid out the same amount. So this could be something where the person who submitted these kind of got the head start on it, got some nice payouts for these bugs that weren't super useful, and then Microsoft was like, okay, yeah, we're not going to pay that much for these anymore. So that it could be, this was like a one-time thing. It worked out really well for this researcher, but might not work out for others. But yeah, I mean, it is an area to be aware of, and they are valid bugs. They should be fixed and whatnot. Definitely not trying to take away from that. But yeah, pretty interesting exploitation scenario, and something that's you would have to have a very specific setup like a kiosk, and some specific goal in mind to make this useful. But still, I mean, like I said, it's not the kind of browser bugs we're used to seeing. Pretty much all the time we cover browser bugs, they're going to be like JIT optimizer bugs or JS core bugs or something like that. Not these kinds of bugs where it has more to deal with like the dialogues and the windows that are being opened up, um, and those kinds of things, as opposed to engine internals, basically.
And I'll also shout out that throughout the post, it's not like grouped up into specific categories, but they also have a little bit of discussion over things like discovering these issues or debugging them. This is one of the first times I've actually seen somebody called, I probably won't say the name of this tool correctly, but Wegley. Which is, it was a tool, we've called it out on the podcast before. I think just when it first kind of came out, it was from someone at Project Zero, as like you could write these little queries to search code, AST parser, just a faster way of, similar in a sense to like semgrep, but not as complex to write the rules. You're really just writing the pattern that it's looking for in a command line to have it run and look for that. One of the first time I've seen called out is like even an option for trying to find this. Is there like trying to find for these specific cases that led to whatever the bugs were? There's one point where it talks about like time travel debugging. So it jumps through a lot of different topics in there that are just kind of mixed in between. that has some interesting points at least. It is worth a read despite the fact that the vulnerabilities do feel a little bit weird.
Yeah, when it comes to the exploitability, at least. All right, so continuing on to some weirder bugs that are in areas that people aren't really looking. We have a SHA-3 buffer overflow. This was discovered in the XKCP or extended Kekkak code package. I probably did not say that correctly. I don't know how you're supposed to say it, but it's the official SHA-3 implementation. So it impacts multiple languages here. Z, I'll let you take this one.
Yeah, and this one, it's not too weird of a bug actually. Let me pull up the commit that talks about this. Yeah, so the issue does exist, or at least they patch integer overflows in a few places. One that gets called out in particular and used as an example, and where kind of the main bug exists is this one, where it's basically just your. So what's going on here? You create your SHA-3 digest, and then the vulnerability happens when you're updating or adding more data to the digest. So it won't happen if you give all the data all at once, but if you, as they give the example here using hashlib in Python, call update with like the 1 byte and then call update with the max end number of bytes. When you do that update, that's where you can have this integer overflow. And that's where this code I was just looking at comes into play, where it's basically taking like the partial block size plus the byte IO index of where is it right now, checking rate in bytes, which I'm assuming is going to be the like max size or something. I didn't actually dig into that code, but effectively what ends up happening is if when this calculation here overflows, got a little addition there if you're watching the stream. When that overflows, it's going to be seen as less than rate in bytes, so it's not going to rewrite the number of bytes there. It actually writes there, so then it calls add bytes with full partial block and all of that. So effectively, that's where you end up getting that overflow, just integer overflow. So not too weird of a bug, actually. Just surprising that's in, this fundamental bit of code that you'd even feel gets exercised often enough, but that's maybe not. Maybe more people are just doing the entire hash at once. Go ahead.
Well, one thing I'll say is like SHA-3 in particular, I don't think is super popular. I don't know if I've ever seen anything that's used it. So that could be a mitigating circumstance, as like, maybe it's not being used super often. Usually you'll see like SHA-2 being used. SHA-3 for a long time did not get any adoption because I think it's a bit slower. It's also needs like support to run properly. It's kind of weird.
Well, I guess it is newer. Like I think it was only standardized, and like I mean, obviously Kekkak existed before it was standardized for SHA-3, but I think SHA-3 was just in 20. I'm just looking it up here. Yeah, 2015.
Yeah, which is pretty recent as far as crypto goes
for hashing. Yeah,
yeah.
And we've moved away from like using just pure hashes for passwords, so that's another place where you're seeing other things being used.
Yeah.
So yeah, that's a fair point to call out as to whether or not SHA-3 is really getting used all that often. Still a little bit surprising. It does rely on this fact that you need to be doing that update or like not all of the data can be provided at once, which is, I think, a limiting factor in terms of how the hashes are going to be used. Can happen. I can imagine more often that you're going to have like, here's my file to hash. Needing to send like all 4 gigabytes of data into it again. That is a big ask in some cases, but given how hashing is used, it's not like an impossible situation. So I'd be interested if somebody actually finds a case where this does end up like rearing its head in the wild. But right now, I believe it's just, PHP, Python, Ruby, whatever else, all these things that are using it, but not a specific instance of the vulnerability being exploited or exposed in an exploitable way. I'd be surprised if there wasn't an instance where it is exploitable, but I don't think any are actually called out.
I mean, to be fair, like bringing back up the sandbox portion of it, if you have like a sandboxed execution in Python or PHP, maybe this could be useful. in some way. But
So that would really fair. So PHP has their built-in safe mode, which is
yeah,
where language exploits kind of actually have a place. Because like with Python, if you've got so in Python, oftentimes like if you need a language issue, you're ending up with the same privilege as you already have by just like import OS. And
yeah, it's generally
executing.
pretty easy to escape the sandbox. Yeah,
Yeah, PHP is the only language that really comes to mind as trying to have some sort of security boundary. Um, in there, although they don't even consider it much of a boundary, but like it does exist to try and stop calling some functions. So that is actually a place where this could be useful.
yeah. Other than that, though, it is kind of a strange scenario. Going back a
Not an
bit to what you were
impossible
saying,
scenario though. Like it's
true.
definitely something that can happen. We just don't have the examples of it, but I would not be surprised at all to find out like somebody can actually point to these languages, because all you really need to do is use update with arbitrary user data and not be restricted on the size. Like it's an ask, but it's not a huge ask. And SHA-3, of course, which is its own limitation.
Yeah. Jumping back a little bit to what you were saying about how it's not really an area you'd expect to see a bug. When you look at the code, it's it almost it kind of hides in the crowd, because with crypto you have a lot of different calculations going on, a lot of different like maths happening here. So areas that would normally like stand out to you to be like, okay, I'm going to look for an int overflow here, that's like everywhere in this crypto code. So it feels like one of those things where it's just easy for these kinds of int overflow bugs to just hide amongst all the other calculations that are going on. And unless you're specifically testing like every possibility of like edge case here, I could see how it could be missed for sure.
Yeah, and they
And
did
the
fix
post
quite a
kind of calls
few.
that out. Yeah, it also fixed. Yeah, there was other bug fixes there too, which I found pretty funny. But yeah, the post even calls that out as like crypto code. It's generally not very nice to look at. Most people avoid it out of hand. They just treat crypto as a black box and are like, okay, I'm going to look at everything else. It's easy to skip over in an audit because it's just exhausting to read. But because of that reason, some of these lower hanging fruit bugs do tend to survive there. I mean, this bug was in there since 2011. It's been there for over 10 years. So yeah, I mean, it's easy for audits to just glance over this kind of code or just not catch these issues. So yeah, not super surprising, I guess, but
Yeah,
still kind of a cool bug.
I think part of that is just when you're auditing something, you're often focusing on that first party code. And if I'm thinking like, oh, what libraries are going to be the most sensitive, the most important or impactful for me to audit, um, I'm probably not jumping to the SHA-3 library. I'm probably jumping to like, oh, are they using like a library that's going to call exec somewhere? You always want to look at those sorts of things. I'm looking at any sort of sanitization, security sensitive things, and the official hashing library feels like the lower risk sort of thing to look at when I'm doing an audit, unless the audit specifically of that. Yeah, I mean, I'm probably going to come up with reasons to avoid reading crypto code.
Yeah, exactly. It does not end up near the top of your list at all. So yeah. Last up, we have a Linux kernel IOU ring exploit that was submitted to KCTF and published last week by KyleBot. And it was essentially a race yielding type confusion in IO-rec init async that could give an invalid free primitive, which is a bit of a fun one. One we don't really see at all. I don't think we've ever covered an exploit scenario like this on the podcast, at least. It is a source of headaches for the author here, but for people reading, it's pretty neat. We have covered IOU ring before, and it is a somewhat complex subsystem, so I won't get into all the background here. This post also like mostly skips over some of that background, instead referring to Chompy's previous post and PQL's post, which we also covered on the podcast.
Yeah, and
Chompy's post,
actually,
which has a lot of the background, was on 128, I believe, for anyone who's interested in that.
and
Go ahead.
yeah, since you mentioned the kind of primitive that he gained out of this, it does remind me a little bit of something we talked about back on episode 52. No, sorry, I have the wrong number completely. Episode 86, where there was the IOU ring bug that would free the wrong buffer. This one is a bit different than that, a little bit more complex, but it does remind me of this older one that I'll drop the link for.
Yeah, so this bug is in IORec and it async, which gets called whenever asynchronous things need to happen, such as like a splice operation or something like that, or in this case, when doing an IO ring setup pull. Um, Problem is, it assumes the IO request is submitted by itself or its own thread, and thus it assigns its own thread context identity to the request work. But that assumption doesn't always hold true. If two tasks try to submit IO requests to the same ring simultaneously, they could end up being submitted into one work queue, which is intended. That's intended design, but it's just not a situation or edge case that IO reckon at async the way it's written here could really handle. So if you have a situation where one thread is trying to exit when IO ring setup IO pull is enabled, for example, it'll try to clean up and finish all the IO events in the work queue. I'll scroll down to the code snippet here for that. But those who can see the stream can notice that if at the end of iterating the queue the list still isn't empty, it'll try to like force the completion with this IO pull complete call, which will eventually call the vulnerable routine, which might have the other thread's context and have the wrong work identity. Here it gets a little bit complicated as to why exactly that's useful. As I understand it, what happens then is later on when the IO event is completed, it'll call this IO put identity function. And the problem there is it'll first check like is the work identity equal to the context identity. Because of the type confusion, that check will pass and it'll fall through to the ref count and free. And if that ref count drops to 0, it'll try to free the identity. But in this situation, because of the type confusion, that identity will end up pointing into the other exiting thread's IOU ring task object, since the underlying identity is inline in the task object. So because of that, an invalid free occurs, which adds what they call an invalid slot into the free list. Basically, what they're talking about there is I brought up the diagram for those who can watch. You kind of have these bounds of the object slab. So you have like hex 0 is the upper slot, and then hex 100 will be a slot for another object. So they have the upper and lower slots. The invalid slot is basically an unaligned allocation being put into the free list. So in this case, hex 90 into the upper slot. Now, this is a bit tricky to exploit because config hardened user copy, which is a fairly recent protection of the Linux kernel, explicitly disallows copying user data across a slot boundary, and it is enabled in KCTF containers, so it is something they have to deal with. So while normally you'd want to try to get some reallocation using a typical heap spray to get control over the rest of the object, the hardened user copy checks will detect that and blow up. So they had to get a bit creative there. The first thing they tried was to see if they could maybe get a spray that didn't use the copy from user API. So they call out like the xatra spray as well as the copy message function via message. Message wasn't really reliable, and the xatra method they didn't go with because they didn't want to burn that technique. Although, funnily enough, that technique was already burned. They just didn't know it.
No, I do
the
appreciate
backstory there is just the fact that KCTF will pay for new techniques. But go ahead.
I do appreciate the fact that he calls out, like he'll at least mention, hey, there is this message or copy message option that doesn't use that uses mem copy, so it can get through that check, but it doesn't but it frees it, therefore it's not usable. But he just calls out at the end there that I detest this method and never tried it. Like not even giving it a shot. But I appreciate the fact he still calls it out there and just let it be known he detests this one, which is fair. Yeah. I mean, it's also just rough to work with anyhow, because of the fact that freeze it, you don't get to hold the memory in place for very long.
Yeah, it's not a great spray primitive. Tried out those methods. They didn't really work out for various reasons, so he went a different direction, which is basically getting the victim object allocated into the invalid slot and then using the valid upper and lower slots to perform the write. So kind of flipping the situation on its head. Instead of using the invalid slot for corruption, using the valid slots for corruption. Just kind of approaching it from a different direction or a different way. From there, talks about the journey of getting that working. Ended up using a timer FD context for occupying the invalid slot to corrupt. Very useful object for primitives, so I'm not surprised there. There's some function pointers that are easy to trigger there. It talks a bit about heap grooming strategies, which is neat, but I'll mostly skip over here. Mostly what's novel there is just like coining the terminology for I think he calls them like digging and fencing
Fencing.
strategies.
Yeah.
Yeah,
Yeah, and I thought that was at least interesting to call out. I'd never really thought about even having a name for them. And they're just like, yeah, there's no, I'm not aware of any names. Yeah, I can't really, since he mentions it, like, I can't really think of giving them a particular name.
yeah,
I guess you will sometimes see it as like making a hole or whatever. Like there is kind of that descriptive name, I guess.
yeah.
Um,
Non short, like a long name, I guess.
yeah, like there are definitely phrases that are used to describe it, but I mean, as far as single word names go, fair enough.
Yeah. Um, So yeah, he ended up using the timer FD context to occupy the invalid slot. Occupies the upper and lower slots with the message seg objects. Again, a very popular object for like heap spraying and exploitation, because you get quite a bit of control over it as an attacker. From there, he used that to overlap the leak timer FD forward and back pointers to the message seg. That gave KSLR defeat. After that gets into code execution, had a few different options there. First tried to go for the like more obvious and easier option of overwriting the timer FD's timer function to get code exec that way. But unfortunately, because that function is called in an interrupt context, returning to userland from ROP turned out to be pretty difficult there, so that wouldn't be a viable route to go. And so we went with the second option, which was to free the timer FD to ultimately corrupt the free list and get an arbitrary write primitive. And that's just because when the invalid slot gets freed again, that forward pointer will get stored in the lower slot with how the metadata is stored, and you have control over that with the overlap. So that's kind of what's going on there. After that, the post talks about getting code exec from the arb right. That's a bit interesting as well. It seems to use a new technique of overwriting the bin format and the formats list for loading executables, and then gets the ability to get PC control with the load binary callback. Yeah, seems to be something new. I don't think I've seen it before. As far as like Kylebot knows, that's also a new technique. But yeah, from there it gets into a bit more of like the struggle of trying to get it to work. A lot of the post is a bit more of that like diary style of like, okay, I tried this and I had these kinds of problems and this is how I overcame it. So that's where it gets into like the day section and all the
So
problems he ended up facing there. But yeah, I mean, overall,
this up to bin format, like that's technically his first 2 days as it works locally, which is
yeah,
more or less what you've covered here. And then yeah, it doesn't work on KCTF environment, and it's figuring out why it doesn't work. Needing to make some adjustments, like you can't actually one thing found it a little bit funny, but he couldn't actually exploit the bug on KCTF, like it wasn't hittable initially, or in an obvious way. Just because KCTF, the only writable location is Tampa Fest, which you can't open in a way to actually hit the bug. So there is kind of that aspect, just working through, but even bin format, I think, is really diving into the Linux kernel exploitation, which, I mean, yeah, we sometimes jump into that with our talks here on the podcast, but try to avoid getting too specific and more generalized things that people can pull out of these,
yeah.
whatever your
Towards the end of the
target
blog
is.
post,
Go
towards
ahead.
the end, it's mainly going into like porting the exploit. So yeah, what I covered is mostly like the local stuff. There is like more to the post that talks about getting it working in the KCTF environment, but like you said, that's getting a bit more specific and yeah, there's a lot to cover there. So that is in the blog post if you're interested in that. Um,
And it's a
these kinds of
really
blog
good
posts
blog
are a good
post.
resource. Yeah,
Like, as a post, this is well written. I felt like things were pretty clear as he went through. I always appreciate seeing the attempts that don't always work out, just sharing all of the knowledge, or not necessarily all, but sharing more than just success. It's a really solid post all around.
yeah. But yeah, it's a really good resource, especially if you're planning on looking into doing like KCTF. The payouts and stuff are really nice, and it is a cool target. So yeah, and these kinds of resources going out there, there's always good information that you can pull from. Towards the end of the post, it does go into talking a bit about Android. I figured I'd bring this up because we talked about this a bit actually back when Chompy's post, the GrappleSec blog post was out and talked about Android. Um, yeah, it seems that IOU Ring is in a bit of a weird place with Android, and it could potentially be abused on some devices. But for the most part, IOU Ring will be like it won't be available to the sandbox. It will be it won't be whitelisted in the seccomp list. So yeah, generally it's not going to be super useful for Android, at least not on like the Pixel devices. But yeah, goes into a little bit of that. But yeah, the main part that I thought was really cool was just that taking advantage of that invalid free, because the closest situation I've had with an exploit I've written was back with the first PS4 exploit I'd written, which was an arbitrary free. That had its own challenges. That I needed an info leak beforehand. This one, for example, you can derive your own because you're not freeing an arbitrary pointer; you're freeing an invalid pointer, and trying to work around that. So yeah, I mean, it's a very unique set of challenges that the author had to deal with here. And yeah, it's just a way of like it's a kind of primitive that I'd never really thought of before or like had any experience with. So yeah, it goes a little bit deep into the heap allocator, but it's very understandable even if you're not super familiar with Linux. The diagrams and stuff really help with that. So yeah, it's a cool primitive, and I enjoyed the blog post. It was a really unique exploit scenario in terms of the initial primitive and whatnot.
Yeah, I'll repeat a second time. Good post all around.
Yeah. All right, so that's all of the full topics that we're going to cover for today. We do have a shout out of a really cool post for exploiting Xbox Game Frogger beyond executing arbitrary unsigned code. This talks about exploiting the OG Xbox with a save game exploit. Um, yeah, it is a really cool post, and you know because I do some console exploitation, I'm a bit biased, I guess. I did find it really cool. He talks about getting like a debug setup going. And some of the RE work there, some of the other existing exploits that were out. There's also some neat techniques with like encoding or encrypting the shellcode to bypass certain things with like when it comes to null bytes. But yeah, like the vulnerability itself is very simple and it's a simple exploit. It's just a straightforward save game buffer overflow. So we didn't want to do like a full coverage of it. But the nature of the system makes it have some cool aspects to it. So I did want to call it out. I think it will be a fun read for some people out there. Beyond the initial vulnerability in the exploit, though. But yeah, if you have anything else you want to add, Z, I'll let you go ahead. Otherwise, we'll wrap it
No
up.
other shoutouts.
All right, cool. So thank you everyone who tuned in. The VOD will be up on Twitch immediately or on other platforms like YouTube tomorrow. We also have previous podcasts up on Spotify, Apple Podcasts, and more links on Anchor. Feel free to join the Discord and follow us on Twitter. Links for those are in the chat or down below. But yeah, with all that said, we'll see you all next week.